input buffer into the NumPy format so that it is digestible to the deep learning algorithms. Now this is it shows simply that we are not going to run the evaluation or training, it's just running inference on the model basically. Now we are saving this. I actually wanted to run it in a small window, but it gave C++ errors. In the interest of time, I couldn't debug it, so I kept it like, let's save the images and show it to the audience.
Okay, just one second.
Yeah.
What are padded info, the two arguments being passed to this function?
That is internal to the GStreamer, where every command line option, right, hyphen, exclamation mark.
No, this pattern info which we are passing to the...
Yeah, that's event handler information. That's where the NumPy buffer, image buffer is stored actually. And that's how we calculate actually the number of frames also here. And buffer to image tensor is a utility function where we actually get the buffer and caps is where we get the actual image into. When I say buffer, it's actually a linear set of values in the RAM. Now we are just trying to rearrange the values in form of RGB matrix, like three-dimensional matrix. That's how it converts into the image, and then we have written the image. Now, get by name is how we set the event handler, and onFrame probe is the function we pass on to it. So it's like setting in fast API or it's like Django, some Cortex, similar to it, if you are from the website. So this is where the main loop function starts. If there is any error comes into the picture, we are going to stop and break it. Finally, we are going to set like, okay, Python is not going to run, and break it. It's a very simple function. I have taken it from a blog, which when I was developing the code for myself a long time back. Now I have included the blog link into our slides also. So any doubts? I will move on to the next demo after any few questions.
It just shows the line where the model is being invoked.
Yeah. Invoked in the sense you want to inference or else like loading into the memory.
Yeah, both actually.
So YOLO and YOLO v90, this is the line which is loaded into the model is initiated, and this is where detector is where we are inferencing actually. Devices goes to MPS is actually where we set it, run it on the MacBook, and image batch is the image that we are currently sending, every live image basically. Detector is a model, YOLO v9 model, and image batch is we pass it to the image. That's how we call the function to run inference basically. That's how it gets done in the API side.
And you are loading the model onto what?
Into the MacBook.
Okay. So what is the size of the model?
I will show you the size of the model, and I think it's 5 MB. You can see YOLO v9.pt, right? PT is what PyTorch standard for loading the models, and the document is 5 MB. That's the size of the model basically.
Okay, but why do you prefer to load the model
into the RAM?
But is it for faster processing if you have loaded the model and then?
Yes, and not every time if you load the model, it will take loading time every time, right?
So it's one time loaded.
It's one time loaded, use it every time.
So it's kind of edge computing, like you have the model and you are getting.
Yes, we are getting the feed here in the same network and running the model edge computing, exactly.
Yeah. Just one second, can you just load this? And what is this image batch that you pass?
It just
what does it represent?
It's just image in the NumPy frame. Basically, NumPy in the sense that it's a 3 into 3 matrix where RGB, R is for one matrix, 2D matrix.
No,
G is
that's okay. So we have a complete video feed, right?
Yeah, we are converting complete video feed into single images. Okay. Single JPEG images or PNG images.
So it's like series of images.
Exactly. Because converting the compressor format into series of images takes most bandwidth on CPU. That's why we have used Decode B, which is automatically loads best metal driver to decode basically. If you have, I don't have Jetson Nano with me, but Jetson Nano has NV decoder. If I had Jetson Nano, I would have written not Decode Bin but NVDEC. It depends upon the hardware that you're trying to run basically.
Okay, and if if you have like a feed, of a video feed, where exactly it's being converted into batches of images?
Okay. Not so here. RTSP is the starting point. Video extra format is where we are getting the image.
Okay.
It's linked. Exclamation is not nothing but a pipeline operator for GStreamer. If you are coming from Linux background, we are passing output of RTSP, this one into the decode pin, and decode pin output is pointed to video convert, and video convert is finally converted into this. Fake sync is where we access the frames into the from memory into our application basically.
Right. So ultimately, that video stream is being converted into series of images. The output is series of images.
Series of images, and output is algorithm run on each of the series of images. So now we have covered the code part. This is the slides are for code part. I will share the slides and also probably provide better documentation for it. And so what I've done is that last year I got a bit bored and actually wanted to extend the algorithm to Telegram bot. The idea of the Telegram bot is that once you send a chat, once you message the Telegram bot, what do you want to detect? It will remember it, and whenever it comes across that object in the stream, it will alert you in the Telegram. Now I'm going to slide show it. There is no audio for it. Yeah. 1 second, guys. Are you guys able to see it, or shall I zoom it out? Okay.
Can you open a new window?
Yeah. So there is no audio for it because